Le Chatelier's principle is when we have an established equilibrium that we're going to disturb that equilibrium by changing the temperature, the concentration, or the volume. In this one page of notes, I'm going to focus on temperature changes. I made a separate video for concentration being changed, and I will make another one for volume being changed. Unlike the concentration changes where the K value stays the same, when you change the temperature for a equilibrium reaction, you will change the K value. So let's write down what is the equilibrium expression for this basic reaction that I have right here. And you'll see that K is going to equal the concentration of our products, which will be B, divided by our concentration of our reactants, which are A. And then let's just again say that it equals 2 like I did in the other video. So when we compare what happens to the equilibrium as it's disturbed and our new equilibrium constant, I am going to call the new equilibrium, because it is going to change, K prime. You'd still calculate it the same way. You'd still have your products concentration divided by your reactant concentration, but it is going to be a new value. So you'll hear me using K versus this K prime right here as we go through this video. Okay, so first off, let's just focus on an exothermic reaction where we increase temperature. So let's take a look at what would happen to the graph. So first off, we again have this where we reach equilibrium around here. That's where again we'd say Q was less than K here, and now we have Q equal to K, and then we disturb the equilibrium right about here. And notice how there isn't that same spike that I had in the other video. We just sort of have these gradual changes in our concentration. That's because we are not changing one of these concentrations, we're changing the actual temperature. So what you can do is include heat in the reaction, or put the word heat. If it's exothermic, you're going to put heat on the product side and almost sort of treat it like it's a product. So what happens to our K value? It is going to decrease. Now, why is it going to decrease? And here's the reasoning why. When the temperature of an exothermic reaction is increased, the equilibrium is disturbed and the reaction will shift to the left to counteract that addition of heat, which is energy, by decreasing the product. So what happens is when we add heat, we're going to decrease the product, so that's why the product started going down, which will then increase the reactant, and our new K value will be less. So what you want to write down here, unlike the last video that I had on concentration changes, our new K prime is actually going to be less than the original. So if the original was 2 in this case, our new K prime, we would just say is going to be less than 2. Okay, just going to finish putting this back on there. There we go. Okay, so that's the first change, is if we have an exothermic reaction and we increase the heat, we actually will decrease the product B, meaning the numerator is going to go down, and then we're going to increase A, the denominator is going to go up. Both of them are going to basically make the K value decrease. All right, let's move on to the next possible change. We're going to stick with an exothermic reaction and take a look at what the graph would look like approximately. So again, we have our equilibrium being established here. Then it's going to be disturbed at that point. So here's where Q equals K. Q would be less than K. And then we have a new K prime. Okay, so again, the K prime compared to the old K. And if you look at it, it's kind of obvious. You've got product higher, reactant lower. So both of those factors are going to end up causing the K value to increase. And again, why that would be is the numerator is going to go up and the denominator is going to go down. Both of those basically show that the new K prime is greater than the old one, meaning that, again, K prime would be greater than 2 if our equilibrium constant was originally 2. Okay, so then what happens if we start to have a different type of reaction called an endothermic reaction? So that means that we'll put heat as a reactant, and the positive enthalpy over here on the side lets us know that we should do that. And you're going to notice that the graph looks kind of the same, and that's because what happens is when you disturb the equilibrium, we have sort of the opposite effect. If we add heat, we're going to decrease our reactant and shift right, and then the product is going to go up and the reactant is going to go down based on the law of conservation. And so we have, again, the product going up, the reactant going down, and the K value increases. So again, I'm just going to kind of do a little faster on this one. The K prime is going to be greater than 2 because, again, we have more product, less reactant because the equilibrium was shifted to the right. And again, remember, heat is not part of the equilibrium expression. So again, let me just write that one more time. So if we write the K value or the equilibrium expression, heat is not included in here. So if B goes up and A goes down, both of those are going to make our new K prime. Let's just do that. Both of those are going to make it greater than 2 if 2, again, was the original K value. I just picked a number. Okay, last but not least, what about if we decrease the temperature? So we take out heat. It's going to shift left, try to replace that. So the product is going to be consumed. The reactant is going to be increased. And again, you can do the same thing. Here we reached equilibrium. Here, we disturbed equilibrium. And then just kind of the reasoning over here on the side is that when the temperature of an endothermic reaction is decreased, it's going to shift to the left, meaning back towards the reactants. The product concentration is going to go down. The reactant concentration is going to go up. Both of those will cause a decrease in our K value. So we'd say, again, our new K prime would be less than 2. So be careful when you change concentration. I talked about that in a previous video. You will have the same equilibrium constant value. However, temperature changes will create a new equilibrium constant that'll either be larger or smaller than the original.